It is December 5th, 1945. 5 aircraft lift off from Fort Lauderdale on a routine training mission. They are expected back before 5 in the afternoon. They never come back. No wreckage, no bodies, no confirmed coordinates. 14 men, gone. And then the rescue plane sent to find them also disappears. Tonight, we are going to follow every thread of this story. The compass that lost its confidence. The ship that vanished with 309 souls aboard and was never found. The sea inside the ocean that has no shores. The fire ice locked in the seafloor beneath one of the world's busiest shipping corridors. And the single most important thing the Bermuda Triangle can teach anyone who pays close enough attention to hear it. Stay with us. This is going to be a long and quiet and fascinating night. If you enjoy our nighttime science journeys, remember to like and subscribe to Earth at Night. We highly encourage our community to discuss the video topics in the comments and react to other comments. It is the most fun when we share our thoughts. Now, let us begin. Tonight, you will travel deep into one of the most enduring mysteries the ocean has ever kept. You will stand on a tarmac in 1945 and watch 5 planes climb into a clear December sky and never come back. You will trace compass needles that lost their confidence, weather systems that formed without warning, and a stretch of ocean so deep that the things it takes from the world it keeps forever. And through it all, you will come to understand that the Bermuda Triangle is not the story most people think it is. It is something more unsettling and, in the end, far more fascinating. A place where human error and geography and physics and chance all meet in the same blue water, again and again, across centuries. Chapter 1. The Flight That Never Came Home. Picture yourself standing at Naval Air Station Fort Lauderdale on the afternoon of December 5th, 1945. The war ended 3 months ago. The base has settled into the quiet rhythm of peacetime operations. Training missions. Navigation runs out over the Atlantic and back again. The kind of afternoon that asks nothing unusual of anyone. At 2:10 in the afternoon, 5 TBM Avenger torpedo bombers lift off from the runway and climb eastward into the blue. The sound of their engines grows smaller, then smaller still, then gone. No one watching them go expects anything unusual. The flight leader is Lieutenant Charles Carroll Taylor. He has more than 2,500 hours in the air. He flew combat missions in the Pacific. He knows these aircraft. He knows this ocean. The mission is called Navigation Problem Number 1, a training exercise, a simple triangular route over familiar water, east toward the Bahamas for a bombing run. Then north over Grand Bahama Island. Then southwest, back to Fort Lauderdale. They are expected home before 5 in the afternoon. The planes go east. The afternoon continues. The tower waits for a routine call. 90 minutes after takeoff, at 3:50 in the afternoon, the tower receives a transmission from Lieutenant Taylor. His voice is steady. The words are not what anyone expected. He says he cannot determine his position. His compass is behaving strangely. His backup compass is also suspect. He believes he is somewhere over the Florida Keys. He believes he is over the Gulf of Mexico. But the Keys are southwest of Fort Lauderdale. The mission had taken him east, into the Bahamas, in exactly the opposite direction. Something has gone wrong inside Taylor's mental picture of where he is. This is the moment everything turns on. Not a storm, not a failure of the aircraft, not something rising from the depths below. One experienced pilot in clear weather, with functioning planes and trained men around him, who has become genuinely convinced he is somewhere he is not, and who is about to make every decision that follows from that single wrong belief. The other pilots hear Taylor over the radio. Some of them are uncertain. One suggests flying east, toward where the sun is setting, and then turning north, to find the Florida coastline. That course would have brought all 5 planes home before dark. But Taylor is the flight leader. He believes they are over the Gulf. He leads them north, then northeast, then further still out over open water, away from land, away from safety. It was not correct. The fuel gauges continue to drop, the light continues to go. By 6 in the evening, darkness has settled over the Atlantic, and the 5 Avengers are flying without visual reference, without a confirmed position, without a clear heading toward anything solid. Taylor continues to transmit. His communications grow more uncertain as the hours pass. He asks other stations for a heading. He repeats his position estimates. The pattern of his transmissions is something that experienced controllers recognize without being told. Not panic, something quieter, something more serious. A capable man who is losing his grip on his own certainty about where he is in the world. And underneath the professionalism, underneath the training, the slow accumulation of a truth that no one on that frequency is ready to name out loud. At 6:20 in the evening, a fragmentary transmission is heard that appears to be Taylor giving his crews instructions for ditching, for putting the planes down on the open ocean simultaneously. In darkness, in seas that are building beneath them. There is no runway, there is no landing strip. There is only the water and the dark and whatever the swells are doing at that exact moment in the North Atlantic in December. And then the signal weakens. The distance between the planes and any receiving station has grown too great. The voice falls below the threshold of what radio can carry. And then there is nothing. No confirmed wreckage was ever recovered. No bodies, no debris field, no coordinates. 14 men in 5 aircraft, gone. And the tragedy did not end there. At 7:27 that same evening, a PBM Mariner flying boat lifted off from Naval Air Station Banana River with 13 crew members aboard. Their mission was to find the 5 missing Avengers. It called in a routine radio check 23 minutes after takeoff, and then it too fell silent. It too was never heard from again. A merchant vessel in the area reported seeing a fireball on the ocean surface around the time the Mariner would have been passing overhead. An oil slick was found the following day. The PBM Mariner was known to be prone to fuel vapor explosions, and that is the most accepted explanation for its loss. 27 men gone in a single evening. No confirmed trace of any of them. The United States Navy conducted a thorough investigation. Every witness was interviewed. Every radio log was reviewed. Every probable flight path was reconstructed as carefully as the evidence allowed. And at the end of all that work, the official conclusion carried 4 words that would echo across the following 8 decades. Causes or reasons unknown. Those 4 words are the seed from which nearly everything that follows in this story grew. Not a cover-up, not an evasion. An honest accounting of what the investigation had produced, which was that despite all available knowledge, the final answer was not available. The ocean had done what oceans do. The depth and the current and the passing time had taken the evidence and kept it. What was left behind was not a closed case with an uncomfortable conclusion. It was an open file with a stamp across its cover that would one day be read not as an ending, but as a beginning. Over the years, researchers would return to Flight 19 many times. They would propose explanations. Most center on Taylor's navigational error, on the disorienting conditions over open water at dusk, on the cascade of decisions that followed one wrong assumption. The most likely final resting position of the aircraft, based on fuel consumption and the last known heading, would place them somewhere in the Atlantic northeast of Florida. There are no definitive coordinates. There is no wreckage to anchor any calculation. What remains is a story that is both completely explainable and permanently incomplete. A flight leader who made an error under genuinely difficult conditions. A crew that deferred to their leader even when some of them believed he was wrong. A sea that gave nothing back. And 4 words stamped across a Navy file that would one day become the first chapter in the longest mystery story the Atlantic ever told. The Bermuda Triangle did not yet have a name when Flight 19 vanished into that December night. That name would come later, assembled from incidents like this one, stitched together into a shape that seemed to mean something. Tonight we are going to follow that stitching all the way to the end. And the first thread begins here. On a December afternoon in 1945, with 5 planes climbing eastward into clear sky, and the sound of their engines fading until there was nothing left to hear. Chapter 2. The ship that swallowed 309 souls. Flight 19 gave us the air. Now we go to the sea. And the sea has a story older than Flight 19, heavier than Flight 19, and in its own way, just as impossible to set down. It is 1918. The war in Europe is still grinding through its final terrible year. America has entered the conflict, and the United States Navy is stretched across the Atlantic, moving supplies, refueling warships, keeping the machinery of an ocean war running. Into that effort, a single vessel stands out for its size, the USS Cyclops. She was launched in 1910. By 1918, she was the largest collier in the United States Navy, 542 feet long, capable of carrying 12,500 tons of cargo. She was not a warship built for combat. She was a workhorse built for endurance, moving coal across long distances, refueling other vessels at sea, carrying the raw materials that kept everything else moving. During the war, she was assigned to carry manganese ore, a dense and heavy metal critical to steel production, the kind of cargo that had weight in every sense. In early 1918, the Cyclops was assigned a specific run. She would take on 11,000 tons of manganese ore in Rio de Janeiro and carry it north to Baltimore, a crossing she had made variations of before. Familiar water, familiar route, familiar purpose. But before she left Brazil, the engineering report contained a detail that should have changed the plan. One of her 2 main engines had a cracked cylinder. The starboard engine was disabled. She was operating on a single engine. The recommendation was to delay, return for repairs, and complete the crossing only when both engines were functioning. That recommendation was noted, and then overridden. The decision was made to proceed. She stopped in Barbados on the 4th of March. That is the last confirmed record of her position. That is the last confirmed moment in which 309 human lives were accounted for. She sent a message from Barbados, weather fair, all well. She then sailed north toward Baltimore and was never seen again. No distress call was ever received. No debris was ever confirmed. No body was ever recovered. No wreckage has ever been found. The USS Cyclops simply ceased to exist somewhere in the waters between Barbados and the eastern seaboard of the United States. Ships that would have expected to encounter her on that route saw nothing. Weather stations recorded no storm severe enough to be the obvious explanation. The silence was total in every direction. She remains to this day the single largest non-combat loss of life in the entire history of the United States Navy. When a loss this large produces this little evidence, the mind searches for explanation. And in 1918, with the world at war, the explanations that came first were not physical, but human. The commanding officer of the Cyclops was Lieutenant Commander George Worley, and Worley himself was something of a mystery before his ship ever became one. His real name was not George Worley. He had been born Johann Wichmann. He was German by birth and had arrived in America years earlier by way of a merchant vessel, eventually assuming the identity of an American acquaintance and building a naval career under a name that was not his own. In 1918, with America at war with Germany, that secret carried a particular kind of weight. Crew members had filed complaints about Worley in the months before the final voyage. reports of erratic behavior, accusations of cruelty toward the men under his command, questions about his judgment under pressure. Some accounts described a man who would appear on the bridge in unusual states, giving orders that the crew could not predict and sometimes could not reconcile with good seamanship. The Navy had investigated. They had reviewed the complaints, spoken to witnesses, and concluded that Worley should remain in command. They had reinstated him. And now he was at sea, with 309 people and a ship running on one engine and 11,000 tons of dense metal ore in her hold. In the weeks and months after the Cyclops failed to arrive in Baltimore, the theories multiplied. German sabotage. A captain who deliberately scuttled his own vessel, his loyalties perhaps lying elsewhere. A cargo that shifted violently in rough seas and capsized the ship before anyone could reach a radio. Each theory had its proponents. None could be confirmed, none could be ruled out with certainty. The Navy investigated all of them. The investigation produced no resolution. The most physically credible explanation, and the one that patient reconstruction of the evidence tends to support, is structural. Manganese ore is exceptionally dense. Loaded beyond optimal capacity into a vessel with compromised structural integrity and a single functioning engine, the Cyclops would have been profoundly vulnerable to any significant weather. The North Atlantic in early March is not a gentle sea. A gale off Cape Hatteras around the 9th or 10th of March, 1918, is the most evidence-consistent scenario. A ship already stressed by its load and its damaged engine encountering sea conditions it could no longer endure, going down fast, too fast for any distress signal to be sent. That is probably what happened, probably. But the word that haunts every reconstruction of the Cyclops is exactly that one, probably. Because without wreckage, without a confirmed position, without any physical record of her final hours, even the most evidence-supported explanation carries that qualifier. And the story has a footnote that is hard to set aside. The Cyclops had two sister ships, the USS Nereus and the USS Proteus. Both were built to the same specifications, the same design, with the same structural characteristics as the Cyclops herself. After the First World War, both ships were sold to a Canadian company and continued working Atlantic routes, carrying heavy cargo. During the Second World War, both Nereus and Proteus vanished in the broad Atlantic, carrying cargoes of heavy metallic ore on crossings that brought them through the same general region of ocean where their sister ship had disappeared 2 decades earlier. Both were lost without confirmed trace. No distress calls, no survivors, no confirmed wreckage. 3 ships of identical design, carrying similar heavy cargoes, all lost without trace in the same broad stretch of ocean. The most credible explanation is the same one that applies to the Cyclops. A structural vulnerability amplified by dense, corrosive cargo and the unpredictable violence of the North Atlantic in bad conditions. The design had a weakness. The cargo exploited it. The sea finished the work. That explanation is not spectacular. It does not require anything hidden or inexplicable. But it does require you to sit with the fact that the same flaw could produce the same catastrophe 3 separate times across 2 world wars and leave almost nothing behind for anyone to find. When we talk about the Bermuda Triangle, we often talk about mystery in the sense of something unknown, something waiting to be explained by forces outside the ordinary. But the Cyclops and her sisters suggest a different kind of mystery. The mystery of how much damage the ordinary can do when the conditions are right. How a cracked cylinder and a heavy cargo and a stretch of rough water and an overridden engineering report can combine into something that erases 309 lives so completely that decades of searching finds nothing to hold. The ocean does not need the extraordinary to be devastating. It only needs the alignment of the ordinary in exactly the wrong order. That is the weight the Cyclops left behind. Not supernatural, not unexplained in principle, but permanent and heavy, and not over. Somewhere beneath the North Atlantic, in water deep enough that the pressure would crush any diving vessel that tried to reach it. The wreckage of a 542-foot ship and the remains of 309 lives are resting in silence. The search has never stopped. The answer has never come. Weather fair, all well, and then nothing at all. Chapter 3. The sea that has no shores. We have been close to the ground, close to the cockpit and the deck. We have followed specific men in specific vessels on specific days. Now we are going to pull back, and the picture that opens up when we do is one of the strangest geographical facts in the entire Atlantic Ocean. The Bermuda Triangle does not sit in the ocean the way most people imagine it. It sits inside a sea, within an ocean, a sea that has no land boundaries anywhere on its entire perimeter. A sea that is defined not by coastlines, but by water moving around it. That sea is called the Sargasso Sea. Every body of water on Earth that carries the name sea or ocean is bounded in some way by solid land. The Sargasso Sea is different. It is bounded on all four sides by ocean currents. To the west, the Gulf Stream moves northward along the American coastline. To the North Atlantic Current carries water eastward toward Europe. To the east, the Canary Current flows south along the coasts of Portugal and Africa. To the south, the North Atlantic Equatorial Current moves westward back toward the Americas. These four currents form a slow rotating boundary around a central patch of relatively still water. Remove any one of those currents, and the Sargasso Sea ceases to exist. Its edges are not fixed on any map that will stay accurate forever. They shift with the water that defines them. The island of Bermuda sits near the center of this current-bounded sea. The triangle that carries Bermuda's name overlaps this region almost entirely. When you fly from Florida to Bermuda, you are not simply crossing the open Atlantic. You are crossing a sea inside an ocean, a sea with no shores, a sea that defines itself by what moves around it rather than by what holds it in place. And on the surface of that sea, something grows that has no equivalent anywhere else in the world. Sargassum, a thick, golden-brown, free-floating seaweed that drifts in vast mats across the surface of the Sargasso Sea, carried by the same slow circular currents that define the sea's boundaries. Sargassum does not grow attached to any seafloor. It has no roots. It floats freely, reproduces freely, and has drifted in these waters for longer than any human civilization has existed. When the surface of the Sargasso Sea is calm, those mats of weed extend to every horizon. The water below them is remarkable, among the clearest in the entire Atlantic, blue in a shade that belongs to no other ocean. In good conditions, visibility beneath the surface extends 60 meters down. You can look into it and watch the light change color as it descends, shifting from blue to violet to a darkness that swallows everything eventually. Beneath those golden mats, an entire ecosystem has developed that exists nowhere else on Earth. Animals that use the weed as shelter, as camouflage, as feeding ground. A world built on drifting, going wherever the currents decide, without any fixed address in the world. In 1492, Christopher Columbus crossed the Sargasso Sea on his first voyage westward. His crew had never seen anything like it. The carpets of floating brown weed stretched in every direction ahead of them and behind them. And to sailors who had learned everything they knew about the ocean in European and Mediterranean waters, seaweed of that thickness had one meaning above all others. It meant land beneath them, shallow water. Reefs, the kind of seafloor that could tear the bottom from a wooden ship without warning. The crew wanted to turn back. The weed meant destruction in everything they had been taught to read about the sea. Columbus noted their fear in his logs. He noted something else as well. His compass in these waters was behaving in a way he had not encountered before. The readings did not align with the North Star the way they did in European waters. He documented this carefully, practically, without invoking the supernatural. he was observing what we now call magnetic declination, a natural and entirely explainable phenomenon where the needle of a compass points toward magnetic north rather than true geographic north, and where the gap between those two points changes depending on where on the surface of the Earth you happen to be standing. Columbus did not have a framework for understanding magnetic declination, but he noticed it. He wrote it down. And the waters that confused his instruments were the same waters we are talking about now. Two anomalies at once, for Columbus and his crew: a sea that looked like a trap and a compass that behaved unexpectedly. Neither was what it appeared to be. Neither was dangerous in itself. But both left marks in the record that would eventually feed a much larger story. The triangle itself has no official existence. It appears on no nautical chart. No aviation weather advisory mentions it. No government agency has ever issued a formal warning to vessels transiting it. Ask 5 different people to draw its edges, and you will get 5 different answers. The most commonly cited shape connects 3 points: Miami in Florida, the island of Bermuda, San Juan in Puerto Rico. Draw those 3 lines, and you get a rough triangle floating over one of the most heavily traveled maritime corridors on Earth. Thousands of ships cross it every year. Hundreds of aircraft fly over it every day. The volume of traffic through this region is enormous. The loss rate, when measured against that volume, is not statistically unusual compared to other comparably trafficked ocean areas. But the stories that came from those waters were specific and strange enough, and gathered densely enough, that a name eventually attached itself to the shape, and once named, the shape became a container. Everything that happened inside it, or near it, or that could plausibly be stretched to reach it, was gathered in. But those lines exist only in the imagination. The ocean does not acknowledge them. Incidents that occur anywhere near this general expanse become eligible for inclusion in the triangle's catalogue. Incidents that occur just outside those loosely defined edges sometimes get included anyway. The shape shifts as needed, and that flexibility is not a weakness in the legend. It is the engine that keeps the legend running. A fixed, precisely defined boundary can be studied, mapped, and statistically evaluated. A shifting one cannot. The triangle stays mysterious, in part because it refuses to hold still long enough to be properly measured. What is real is the geography. The warm, current-bounded sea within the Atlantic, the seamounts and trenches beneath it, the weather patterns that form over warm tropical water, the magnetic variation that has always existed here, the depth that swallows evidence, the currents that move things far from where they started. These things are real. They were here before the triangle had a name. They will be here long after the name has faded. And they are, as we will discover across the chapters ahead, more than enough to explain what the legend has gathered around them. The geography did not create the mystery, but it created the conditions in which mysteries were possible. And that is a distinction worth holding on to as we go deeper into this story. But first, before the explanation, it is worth staying here just a moment longer, in the stillness at the center of the Sargasso Sea, where the currents move around but not through, where the weed drifts in golden mats on clear blue water, where Bermuda sits at the heart of something that has no fixed edges and no solid walls, where the sun sets slowly into water so clear you can watch it go, and where the idea of the triangle began not with any single mystery, but with the oldest human response to a place that feels genuinely different from the world around it. A place this old, a sea this strange, a history this heavy. The response that says, there must be something here, something we have not yet found, something the water knows and is not telling. Chapter 4. Where the compass loses its nerve. The compass is one of the oldest navigation instruments in human history. A needle that aligns itself with an invisible force and points, reliably, in one direction. For centuries, that reliability was the foundation of everything. You could not cross an ocean without it. You could not hold a course in fog or darkness or open sea without something that would tell you, quietly and consistently, which way was which. But the compass has a secret, and in the waters of the Atlantic that we have been traveling through tonight, that secret has played a role in more confusion, more disaster, and more mysterious disappearances than almost any other single physical fact. The secret is this: a compass needle does not point to true geographic north. It points toward magnetic north, and those two norths are not the same place. True geographic north is the top of the Earth's rotational axis, the fixed point around which the planet spins. It is where the lines of longitude converge. It is the north that maps are built around. Magnetic north is something different. It is the location toward which the Earth's magnetic field lines converge at the surface of the northern hemisphere, and that location is not fixed. It moves. It has been moving for as long as the Earth has had a magnetic field. In recent decades, magnetic north has been drifting northward across the Canadian Arctic at a rate that has accelerated over time. In some years, the drift has exceeded 50 kilometers. It is moving right now. Tonight, as you rest, and this story carries you, magnetic north is not quite where it was this time last year. The angle between where a compass needle points and where true north actually is has a name. It is called magnetic declination. This angle varies depending on exactly where on the surface of the Earth you are standing, and it changes slowly over time as the magnetic field shifts. In some places, the declination is small. The two norths almost align. A compass is nearly as good as a map. In other places, the declination is significant. A compass in those regions will point you in a direction that is meaningfully different from where true north actually lies. At the speed of a ship over 3 days at sea, a single uncorrected degree of compass error can place you miles from where you believe you are. Over a week, further still, the error does not announce itself. The ship moves steadily. The crew performs their duties. The compass does exactly what a compass does. And the accumulated distance between the ship's actual position and its believed position grows silently with every nautical mile. In earlier centuries, before the nature of magnetic declination was understood, before the charts existed that allowed sailors to correct for it with precision, the behavior of a compass in these Atlantic waters could produce genuine disorientation. And the disorientation it produced did not feel like a navigational correction problem. It felt like the sea was doing something unexpected, something the instrument was not prepared for. Several hundred years ago, a geographic phenomenon existed in this region that added another layer of confusion. A line called an agonic line passed through or near the Western Atlantic. An agonic line is a zone where magnetic declination happens to be zero, where magnetic north and true north align. Sailors crossing the Atlantic from European waters, where they had learned to correct for a particular and familiar pattern of magnetic variation, would find as they reached these western waters that their compasses seemed to agree with the stars. The compass appeared to point true north rather than magnetic north. To an experienced European navigator, a compass that agreed perfectly with the stars in unfamiliar waters did not feel like relief. It felt like the instrument had shifted, like the world was doing something different here than it did at home. That suspicion was not entirely wrong. The world was doing something different, just not something dangerous. The agonic line was simply the place where the correction became unnecessary. But for a sailor who had internalized a correction without understanding why, the disappearance of the need for it felt like an anomaly. Those agonic lines migrate over centuries as the magnetic field evolves. The alignment that disoriented early Atlantic navigators no longer exists in the same location, but its effects on the historical record were real. Accounts of compass strangeness in these waters go back centuries. And because no one at the time had the framework to understand what was actually happening, the strangeness went into the record as strangeness, as something worth noting, as something the sea was doing. The Earth's magnetic field also responds to forces that come from outside the planet entirely. The Sun, 93 million miles away, is not simply a source of light and warmth. It is a source of charged particles, of electromagnetic radiation, of events that reach the Earth's magnetic field and temporarily distort it. Solar flares and what are called coronal mass ejections are eruptions from the Sun's surface that release enormous quantities of charged particles into space. When those particles reach Earth, they can compress and deform the magnetic field for hours or even days at a time. During strong solar events, compass needles around the world can behave erratically. Radio communications degrade. Electronic navigation systems lose accuracy. The magnetosphere that normally shields and stabilizes the field is pushed inward on the side facing the Sun, stretched outward on the side facing away, and the calm and predictable behavior of instruments that depend on it becomes something else entirely. These events are now monitored, predicted, and communicated through space weather services that operate continuously. Pilots and mariners today receive warnings before significant solar activity begins to affect their systems. Historically, those warnings did not exist. A solar storm arrived without announcement. A ship crossing the Western Atlantic during a period of elevated solar activity might find its compass behaving unusually, its radio reception degraded, and its ability to confirm position by celestial navigation reduced if the night sky was also obscured. Every component of the navigation picture could be compromised simultaneously, through no mechanical failure, through no human error, through nothing more than the Sun doing what the Sun does. 3 minutes of light travel away, caring nothing for the ships in its magnetic shadow. None of this was understood. None of it had a name. The instrument behaved strangely. The sea got the blame, because the sea was there, beneath you. Because the sea was where the danger felt like it was coming from. Because the Sun was too far away and too necessary to be the cause of anything. The invisible forces that moved the needle were far easier to feel as coming from below than from above. The ocean was unknown. The ocean was dangerous. The ocean was the thing you had to cross. It made more sense as the origin of the trouble than a star 93 million miles in the other direction. The compass and the forces that confuse it are one thread in a larger fabric of physical explanation. They do not account for every loss this region has witnessed. They do not close every open file, but they explain something important about why the triangle gathered stories so readily. Why experienced men in good ships sometimes felt the world shifting under them in waters that should have been familiar. Why the record of this region carries, across centuries, a recurring note of instruments not quite doing what instruments are supposed to do. The needle moved, and the ship, trusting the needle, moved with it, into water that was not home. In the chapters ahead, we will follow the other forces that shape this region, the currents that carry things far from where they started, the weather that builds faster here than almost anywhere else on the Atlantic. The human body and what it does when the horizon disappears and the instruments disagree. Each of these forces is real. Each has played a role in real losses. And each, when understood, makes the triangle less mysterious and more honest, less supernatural, more simply, profoundly, honestly dangerous, in the way that powerful and complex systems are always dangerous, not because they are evil, but because they are large, and we are small, and the margin between them is sometimes thinner than we would like. Chapter 5. The Ocean's Invisible River. Beneath the surface of the Atlantic, running northward along the eastern coast of the United States, and then curving out into the open ocean toward Europe, there is a river. Not a river in the way that word usually travels. Not a river with banks, with visible edges, with a defined channel you could point to on a map. But a river in every functional sense that matters. A moving body of water with direction, with speed, with temperature, with force. A river that has no shore and no end, and carries more water than all the rivers on the surface of the earth combined. It is called the Gulf Stream. And for anyone navigating the waters of the western North Atlantic, including the waters we call the Bermuda Triangle, the Gulf Stream is never simply background. It is an active participant in every crossing. The Gulf Stream originates in the Gulf of Mexico, where warm tropical water is gathered by wind and pressure into a current that flows northward through the narrow channel between Florida and the Bahamas, and then up the American coastline. The water inside the Gulf Stream is measurably warmer than the water surrounding it. In some places, the temperature difference between the stream itself and the surrounding ocean is 10 degrees or more. From above, in satellite imagery, the boundary of the Gulf Stream is visible as a color difference in the water. The boundary is not a gradual fade. In places, it is almost a line. On one side, cooler, darker ocean water. On the other, warmer, slightly more vivid blue that belongs to the current itself. From a ship at sea, crossing from the surrounding ocean into the stream, the color of the water changes. The temperature of the air above it changes. The behavior of the waves changes. Sailors who crossed these waters regularly in the age of sail knew the Gulf Stream not by charts but by feel, by the color of the water, by the warmth of the air. By the way, the swells moved differently inside it than outside it. The Gulf Stream moves. At its fastest points, through the Florida Strait, it flows at speeds exceeding 4 knots. That is faster than many sailing vessels of earlier centuries could achieve under favorable wind. 4 knots is a river moving seriously. A vessel caught in it without knowing is not being gently nudged. It is being carried, reliably, silently, in a direction that may or may not align with where the ship believes it is going. Consider what this means for a navigator who does not account for it. A ship sailing a straight compass heading from one point to another, over a crossing that takes 3 days, is not simply covering the distance in a straight line. It is covering that distance while the ocean beneath it is also moving. If the ship's path crosses the Gulf Stream, the current adds a sideways component to every mile the ship travels. The vessel arrives not where the compass heading pointed, but somewhere offset from that destination by the accumulated push of millions of tons of moving water. The navigator who does not know this, or who knows it but underestimates it, walks off a ship at the wrong port, or does not walk off at all. The water delivered them somewhere else, somewhere that was not on any plan. And the ship's log, recording only heading and speed without accounting for current set and drift, shows a vessel that should have arrived exactly where it aimed, but did not. And the question of why becomes the kind of question that stays open for a very long time. The Gulf Stream does not flow in a perfect line. It meanders. It bends and curves as it moves northward, forming loops and waves in its path that shift over weeks and months. Where these meanders curve strongly enough, they pinch off. A rotating mass of Gulf Stream water separates from the main flow and spins independently as what oceanographers call an eddy. These eddies can be miles across. They can persist for weeks before they finally dissipate, mixing their warmer water into the surrounding ocean. A vessel sailing into an eddy encounters something that behaves differently from the water it was just crossing. The currents at its edges move in unexpected directions. The temperature changes. The surface conditions shift. For investigators trying to reconstruct what happened to a vessel or aircraft lost in this region, eddies are a serious complication. Debris scattered by an eddy may surface dozens of miles from where the original event occurred in a direction that makes no sense from wind alone. The eddy was not plotted on any chart at the moment of the incident. Its presence cannot be confirmed retroactively without oceanographic data that was not being collected at the time. The search team looks for wreckage where the current and the wind should have carried it, and finds nothing, because the eddy carried it somewhere else entirely, into warmer water that accelerated decomposition. into a current that took it in an unexpected direction, into the open Atlantic, where the ratio of wreckage to ocean surface is a ratio that does not favor finding. North of Puerto Rico, along the eastern boundary of the Bermuda Triangle, the ocean floor drops into a place that adds another dimension to everything we have been talking about. The Puerto Rico Trench is the deepest point in the entire Atlantic Ocean. At its lowest point, it reaches approximately 8,376 meters below the surface. To put that number in terms that carry their true weight, consider this. Mount Everest is approximately 8,849 meters above sea level. If you placed Mount Everest at the bottom of the Puerto Rico Trench, its summit would still be more than 400 meters underwater. The deepest point in the Atlantic would swallow the tallest mountain on Earth and leave room above it. When a vessel sinks in the waters above the Puerto Rico Trench, it does not come to rest on a shelf where future technology might one day reach it. It falls through water under pressure that increases with every meter of depth. It falls through darkness that no natural light has ever reached. It falls until it reaches a sea floor where the pressure is more than 800 times the atmospheric pressure at the surface. At those pressures, materials that would survive for centuries on land are compressed and destroyed. Wood, fabric, the softer materials of human life disappear. Even metal changes. Wreckage that might have provided the definitive answer to what happened to a ship or aircraft simply falls past the reach of any current investigation. This is not metaphor, this is physics. The ocean here is not merely deep. It is deep enough to permanently erase the physical record of what happens inside it. The Gulf Stream and its eddies can scatter the surface evidence across hundreds of miles. And the trench below can take whatever sinks and lock it in a place that human hands have never touched and may never touch. No current diving technology can operate at those depths. No remotely operated vehicle has searched those specific coordinates. The floor of the Puerto Rico Trench has been mapped by sound waves, bounced off its surface, but it has never been walked. It has never been examined with any instrument that could identify the wreckage of a ship or the scattered components of an aircraft. Whatever rests there in a darkness and a pressure and a silence that is as permanent as the sea floor itself. This is why so many of the triangle's losses produced so little physical evidence. Not because something extraordinary removed it, because something entirely ordinary, something that has been doing this to the debris of shipwrecks and aircraft for millions of years, is simply doing what it has always done, moving things, burying things, keeping them. The river runs, it has always run, and everything that falls into it eventually goes somewhere that cannot be followed. Chapter 6. Weather that changes its mind. The ocean beneath this region is warm. Warm in the way that tropical and subtropical water is warm. Not the comfortable warmth of a beach in summer, but the deep, persistent, energetically loaded warmth of water that has been gathering heat from the sun for a long time. And warm water is not simply a temperature. It is stored energy. It is potential. And in this part of the Atlantic, that potential becomes weather in ways that are faster, more dramatic, and more dangerous than most people who have never sailed or flown here could imagine. When warm, moist air rises from the surface of this ocean and encounters the cooler air of the upper atmosphere, instability builds. The air that rose creates a partial void at the surface that pulls more air inward to replace it. That new air is also warm and moist, and it also rises. The cycle feeds itself. Clouds begin to form. At first, they are ordinary looking. The flat-bottomed, rounded top cumulus clouds that you can watch from any sunny field and feel completely unthreatened by. But over warm ocean water, those clouds do not spread outward the way they do over cooler surfaces. They grow vertically. They climb. They push upward at 10,000 feet per hour or more while appearing from the side like relatively modest formations. From a cockpit or a deck, The scale of what is happening inside those clouds is invisible. You see the shape. You do not see the vertical velocity. You do not see the updrafts and downdrafts churning inside a column that looks, from a safe distance, like an ordinary afternoon thunderstorm. You see the outside of a machine you are about to fly into. A sky that looked safe at noon may contain something entirely different by 2 in the afternoon. Not because anything unusual has occurred, because this is how this weather works. This is the ordinary meteorology of warm tropical ocean. The clouds grew exactly as the physics required. The change was not a surprise from the atmosphere's perspective. It was, from any pilot or sailor's perspective who was not watching it every minute, a surprise that arrived before the warning. Above those growing cloud columns, lightning begins to discharge. Rain falls in amounts that have no relationship to what rain looks like on land. A mature tropical thunderstorm can drop an inch of rain in 10 minutes. Visibility drops to what pilots describe as 0-0. Wind, calm moments before, begins to move with serious purpose. And what was a comfortable crossing becomes something that demands everything a crew has. Not just skill, not just training, attention, continuous, complete, uninterrupted attention. Because in this weather, the situation a minute from now may bear no resemblance to the situation right now. But the concentrated fury of a thunderstorm, powerful as it is not the most dangerous weather phenomenon this region produces for small vessels and low-flying aircraft. That distinction may belong to something far less discussed and far less understood by people who do not spend time on open water. Waterspouts. A waterspout is a rotating column of air and water vapor extending from the base of a cloud to the surface of the ocean below it. From a distance, waterspouts look like the funnel clouds of land tornadoes because they are structurally similar to land tornadoes. Some are relatively weak, curiosities, things that small boats can steer around if they see them in time and the distance is sufficient. Others carry winds that would qualify as significant tornadic force over land. They form quickly, often without the clear atmospheric warning signs that allow tornado watchers on land to issue advance notice. They can appear in clusters, with several forming within visual range of each other, creating a situation where steering around one means steering toward another. They move erratically. They do not travel in predictable straight lines. A waterspout that was moving northward may turn in any direction without signal. Waterspouts are common in this region, particularly in the warmer months when the sea surface temperature is highest and the contrast between the surface and the upper atmosphere is greatest. They do not generate the same warning infrastructure that hurricanes do. Weather radar may show the parent thunderstorm but not the waterspout itself, which is a surface feature too narrow and too brief to appear clearly on most radar returns. Many waterspouts form, do damage, and dissipate within 20 minutes without any official weather record of their specific existence. They are not reported if no one survived to report them. They are not mapped if no radar captured them. They are, in the truest sense of the word, invisible hazards, present, active, gone. A small vessel or a low-flying aircraft encountering a waterspout at close range does not have the structural margin to survive sustained engagement with it. The encounter is brief. It is violent. It may produce no radio call because the radio operator had no time, and in the aftermath, the waterspout itself has moved on or dissipated, leaving no physical evidence of its presence except what it destroyed. Beyond waterspouts, the region is subject to squall lines. A squall is a localized, intense burst of wind and rain that develops quickly and dissipates quickly. A squall line is a chain of squalls organized along the leading edge of a larger weather boundary. They can form and intensify faster than a weather radar cycle updates. They can appear on the horizon as a line of dark clouds that does not look immediately threatening. You have time, you have options, and then you do not. Inside a squall line, winds can jump from 15 knots to 50 knots in under a minute. Visibility drops to near zero. The wind reverses direction as the system passes through, producing what mariners and forecasters call confused seas. That phrase sounds almost gentle until you understand what it means physically. When wind comes from one direction, waves align to that direction. When the wind shifts sharply, a new wave pattern begins to build on top of the existing one. For a period, waves are arriving from multiple directions simultaneously. The surface of the water no longer has an up and a down in any consistent sense. It has competing geometries, all demanding different responses from a hull at the same time. A vessel that would handle any of these wave patterns alone may struggle badly when they all arrive together. A small boat in confused seas is not simply being hit by waves, it is being hit by a problem with no single correct response. Every choice of heading puts the bow into something coming from a different direction. This is not unusual meteorology. It is not exotic or rare. It is the weather of warm, dynamically active ocean, behaving in accordance with well-understood physics in the way it always has. The difference between a crossing that passes through this weather safely and one that does not is often not preparation or skill, it is timing. A system that developed 2 hours earlier changes the encounter entirely. A forecast that did not capture the rate of development leaves a crew making decisions based on a sky that no longer exists. The weather here is not malicious. It does not have a preference for this particular triangle of water. It is simply doing what warm ocean weather does, building when the conditions allow, moving faster than expectations, and sometimes arriving exactly when the margin between safety and disaster is at its narrowest. When the boat is small enough, and the timing is close enough, and the squall line arrives from exactly the wrong direction, the weather does not need to be extraordinary. It only needs to be exactly what it always is. And that, in the right circumstances, is more than enough. In the next chapter, we are going to leave the ocean surface and the sea entirely and climb into the cockpit. Because some of what happens in these waters happens not to the ship or the aircraft, but to the person flying or sailing it, to the body, to the inner ear, to the part of the human nervous system that is supposed to tell you which way is up, and what that system does when the horizon disappears and the instruments say one thing and your body says something completely different is one of the most important and underappreciated forces in the entire story of the triangle. Chapter 7. The night the sky felt wrong. Inside your head, just behind and above your ear canal, there is a structure so small you could hold it on a fingertip. It is called the vestibular system. It is made up of fluid-filled chambers and tiny sensory hairs that detect the motion of that fluid. When your head moves, the fluid moves with a brief delay, bending the hairs, sending a signal to the brain. That signal is processed instantly, automatically, below the level of any conscious thought, and converted into a seamless understanding of your orientation in space. Which way is up? Which way is down? Whether you are tilting, whether you are turning, whether you are accelerating or decelerating. The vestibular system does this continuously, all day, every day, from birth until death, without asking for your attention. It is one of the most reliable sensory systems the human body possesses, and under the specific conditions found in the skies above the Bermuda Triangle, it can become your deadliest enemy. Spatial disorientation is what pilots call it. It is the condition in which the inner ear is receiving signals that the brain interprets as accurate information about the body's orientation, but those signals are wrong, not slightly wrong. Decisively, convincingly wrong. The vestibular system was built for a world of solid ground and visible horizons. When those references disappear, it begins to fill in the gaps using physics that apply to normal human movement on solid surfaces. But aircraft do not move the way bodies move on solid surfaces. An aircraft in a coordinated banked turn produces centrifugal force that perfectly simulates straight and level flight for the inner ear. The inner ear feels no turn. The aircraft is turning. If the pilot corrects toward what the body reports as level, the pilot has introduced a bank. The aircraft, previously in a gentle turn, is now in something else. And the harder the pilot fights the instruments to trust the body, the worse the situation becomes. This is called the leans. Pilots know it by name. They train for it, they discuss it in briefing rooms, and they still experience it. Because knowing that the body will lie to you does not stop the body from lying. It only means you have a framework for recognizing the lie when it arrives. That framework requires attention. It requires cognitive space. And cognitive space is exactly what starts to compress when everything else is also demanding it. Pilots are trained for this, not trained to eliminate the sensation because that is not possible. Trained to recognize it, trained to believe the instruments when the body disagrees. The mantra is direct and has never changed. Believe the gauges, trust the panel, the body is lying. But training does not override biology without effort. The sensation of spatial disorientation is not a vague unease. It is an absolutely convincing physical experience of tilting or turning or climbing that the body reports with the same confidence and the same urgency as genuine sensation. Fighting against it requires deliberate, continuous, cognitively demanding effort. And that effort is being demanded from a pilot who may already be managing a communication problem, a navigation uncertainty, a fuel concern, or the weather conditions we discussed in the last chapter. Every additional demand on attention is attention that cannot be given to maintaining instrument discipline. Every second of distraction is a second during which the body's false report is going unchallenged. Over open ocean at night, the conditions that produce spatial disorientation are near perfect. There is no horizon. The water below reflects no light and offers no reference. There are no landmarks, no roads, no city lights, no ground features of any kind. The sky and the sea merge into a single dark field with no visible distinction between them. Pilots who fly these routes at night describe the experience of looking out the window and seeing nothing. Not darkness in the way a room is dark when the lights are off, a deeper kind of nothing. A visual field that provides zero information about orientation because there is no fixed object anywhere in it. A full moon over flat, calm water can create an opposite problem, a reflection so complete that the surface of the ocean looks like sky, and the actual sky above the aircraft looks like another ocean below it. The horizon, in those conditions, can appear to be everywhere at once, and none of the options it presents are correct. And if those instruments are also behaving inconsistently, if they are disagreeing with each other as they can under electrical stress or turbulence or pitot tube icing, then the pilot has no reliable external reference, no reliable instrument reference, and a body that is actively providing false information with complete conviction. This is not an exotic scenario. This is the ordinary condition of nighttime flight over open tropical ocean in the region of the Bermuda Triangle. This is what every pilot who has ever made this crossing has flown through. Most of them arrived. Their skill, their training, their instrument discipline, and the fact that they did not encounter any additional compounding problems allowed them to complete the crossing without incident. But the margins they were operating in were real, and the pilots who did not arrive were not necessarily less skilled. They may simply have encountered those conditions at a moment when one additional problem was enough to tip the balance. Wind shear adds a dimension that is particularly dangerous during departure and arrival, but is also hazardous at cruising altitude. Wind shear is a rapid change in wind speed or direction over a short distance. In the warm, dynamically active air above this region, wind shear is not unusual. It exists at the boundaries of weather systems, at the edges of the Gulf Stream where temperature and therefore pressure differences create horizontal air movement, and within and around the rapidly growing cloud columns we discussed in the previous chapter. When an aircraft encounters unexpected wind shear at cruising altitude, the change in headwind can alter effective airspeed. An An unexpected headwind component of 20 knots, sustained for 2 hours on a flight already planned to the edge of fuel reserves, closes the margin entirely. The pilot now faces a flight that was designed to arrive with a comfortable fuel buffer and will instead arrive at the destination, if it arrives at all, with nothing to spare. These compounding interactions between the human body, the instruments, the weather, and the fuel state are not sequential problems, they are simultaneous ones. They do not arrive in a polite order that allows each to be addressed before the next appears. They arrive together. They demand attention together. And in the dark, over the featureless water, without a horizon to stabilize the inner ear and with instruments that may be disagreeing with each other and a weather system growing faster than the forecast suggested, the cockpit becomes a place where the difference between arriving and not arriving is measured in very small increments. Flight 19 was not flying at night when it began, but it was flying at night by the time it ended. 5 experienced men in capable aircraft over familiar water, with all the training the United States Navy had provided. And somewhere in those dark final hours, with the fuel going and the radio calls growing fewer and the ocean offering nothing to navigate by, all of it was not quite enough. That is not a failure of courage or competence. It is not a mystery that requires anything supernatural to explain. It is an honest accounting of what these conditions are capable of producing. The body telling the pilot one thing. The instruments, to whatever degree they were still reliable in those final hours, telling something else. The dark around them offering nothing. And the fuel, the one clock that had been running since 2:10 in the afternoon, approaching the end of what it had to give. An accounting that makes the triangle no less significant, but makes it, perhaps, something closer to true. Chapter 8. The electronic fog. Not every account of unusual experience in the Bermuda Triangle comes from a wreck report or a naval investigation. Some of the most compelling testimony comes from people who passed through this region, encountered something they could not explain, and arrived alive on the other side to describe it. One of those accounts belongs to a man named Bruce Gernon, and it is worth taking seriously. It is the 4th of December, 1970. Bruce Gernon is 23 years old. He is a licensed pilot with several years of experience flying the routes between Florida and the Bahamas. He has made this crossing before. The weather forecasts for the day are favorable. The aircraft is a Beechcraft Bonanza, a capable single-engine plane commonly used for exactly this kind of island-to-island flight. Gernon has his father and a business associate aboard. The departure point is Andros Island in the Bahamas. The destination is Palm Beach, Florida. The flight should take approximately 75 minutes under normal conditions. Everything about the day is routine. Gernon takes off from Andros and begins his climb to cruising altitude. Ahead of him, he notices a cumulus cloud forming over the water. This is not unusual. Cumulus clouds form over warm ocean water constantly, especially in the afternoon hours when surface heating is at its highest. Gernon climbs to get above it. The cloud climbs faster than he does. He climbs again. The cloud continues to match his altitude, growing vertically at a rate that he has not observed before. He looks back toward Andros Island and sees that the cloud has not stayed ahead of him. It has spread to encircle him. A complete ring of rapidly developing cloud, a full circle of weather, has formed around his aircraft while he was climbing. And at the center of that ring, directly ahead, something opens. A tunnel. Gernon describes a rotating, spiraling channel through the cloud. Not a gap, not a clearing. A defined tunnel shape, lined with rotating cloud, open through the center. He makes a decision. He flies into it. Inside the tunnel, his instruments begin to behave unusually. The compass, which had been steady, starts to move, slowly at first, then continuously, rotating without settling on any heading. The altimeter shows fluctuations that do not correspond to his control inputs. Static fills the radio with a sound that makes communication difficult and then impossible. He calls Miami, "Approach control." They tell him they do not have him on radar. He is flying through this tunnel at altitude, in a region of the sky where, as far as Miami is concerned, he does not exist. The aircraft is real. The instruments are telling him it is real. But to every external authority with the technology to confirm his position, he is simply absent, not lost, not emergency, not anywhere, on any screen, absent. Guernon estimates the tunnel passage took several minutes. He cannot be precise. His attention was fully consumed by managing the aircraft through conditions he had never trained for and had no framework to anticipate. And then the rotating cloud walls thin. The structure collapses around him, and he emerges into something else entirely. He emerges into what he describes as a gray fog. A uniform, featureless gray in every direction. No sun visible, no ocean visible, no horizon. His instruments continue to behave erratically. He has no confirmed position. He continues flying on his last known heading toward Florida, managing the aircraft by the instruments that are still giving consistent readings, calling Miami repeatedly. And then, 34 minutes after takeoff, the fog begins to thin. It parts around him, and below him is Miami Beach. This requires a moment to sit with. Guernon departed Andros Island. Miami Beach is more than 100 miles from Andros. A flight that should have taken over an hour has apparently covered that distance in 34 minutes. He lands at Palm Beach 47 minutes after takeoff, a crossing that normal conditions would have required 75 minutes to complete. In the years since that flight, Guernon has written extensively about the experience. He calls what he flew through electronic fog. He believes he experienced a genuine atmospheric anomaly involving time and space that cannot be accounted for by conventional physics. His account is specific, internally consistent, and has not changed significantly across decades of retelling. He has passed multiple psychological evaluations. He is not confused about what he experienced. He is reporting, as accurately and honestly as he can, what happened on that December morning in 1970. It is important to treat this account with the care it deserves. That means neither dismissing it nor accepting its most dramatic interpretation without examination. What science can account for is significant. Rapidly developing cyclonic convective cloud formations over warm tropical water are real and documented. The behavior Guernon describes in the cloud ring around his aircraft is consistent with what is known about fast-forming convective structures in this environment. The warm sea surface and the atmospheric instability above it can produce cloud formations that develop with a speed and a rotational geometry that a pilot who has not encountered them before would find genuinely unlike anything in their experience. The physics are known. The experience of encountering them is not routine. Both things are true at the same time. Instrument malfunctions of the kind he experienced, spinning compass, fluctuating altimeter, radio static and dropout, are all consistent with what aviation meteorologists describe as the electromagnetic environment inside or near severe convective thunderstorm cells. Large electrical charges build inside those cells. Those charges produce electromagnetic fields strong enough to interfere with the avionics aboard a small aircraft. The experience of flying inside that environment while the radio reports you as invisible to radar is not impossible. It is unusual, but it has physics behind it. Physics that operate in this region of the Atlantic regularly, silently, without news coverage and without investigation, on days when the aircraft that encounters them also arrives safely and files no unusual report. The vestibular disorientation we discussed in the last chapter is also relevant here. Inside a spiraling cloud structure under high workload, with instruments behaving erratically and no visual horizon, a pilot's subjective experience of time can compress. Psychological research on high-stress events consistently shows that time perception distorts under acute cognitive demand. Events that lasted minutes may be recalled as seconds. Seconds can expand into what feels like much longer. The subjective experience of the flight may not align with the objective elapsed time as reliably as it would on a calm, routine crossing. What science cannot account for, with the data available, is the apparent distance anomaly. If Gernon genuinely covered more than 100 miles in 34 minutes in an aircraft whose cruise speed would require over 50 minutes to cover that distance, something unusual happened. The records that might have allowed a definitive reconstruction of exactly what, the radar logs, the air traffic control tapes, the precise instrument readings from the aircraft, were not retained beyond the standard one-year holding period. They no longer exist. The anomaly therefore remains exactly what it is: a reported experience by a credible witness that science can partially explain and cannot fully resolve. That is not an invitation to supernatural interpretation. It is an honest acknowledgement that some accounts of unusual experience fall into the careful middle ground where dismissal is as intellectually dishonest as uncritical acceptance. Gernon is not the only pilot who has described unusual atmospheric encounters in this region. He is simply the one who described his with the most detail, the most consistency, and the most willingness to keep the question open rather than closing it with an answer he could not fully support. His account survives scrutiny, not because it proves anything. It survives because it honestly represents what he experienced, what he observed, and where the limits of his explanation end. Something happened to Bruce Gernon on December 4th, 1970. Most of it has explanations that hold under examination. One element does not hold as cleanly. And that element, precisely because it does not resolve neatly, deserves to be carried forward not as proof of anything extraordinary, but as an open question in a story that has always had room for open questions. The fog cleared. He landed, and he has spent more than 50 years trying to explain what happened in between. Chapter 9. The Myth That Made Itself. For the first 8 chapters of this story, we have been inside the triangle, inside the cockpits and the cargo holds, the cloud formations and the current systems, the magnetic fields and the deep trenches. We have been looking at what actually happens in this stretch of ocean and sky. Now we are going to step back. We are going to look at something different, not what happens in the triangle, but what happened to the idea of the triangle, how it was assembled, who assembled it, and why the assembly was so effective that even the most rigorous correction barely slowed it down. The Bermuda Triangle, as a named, defined, and culturally recognized phenomenon, is largely the creation of one book published in 1974. The author was Charles Berlitz, and the book was simply titled The Bermuda Triangle. Berlitz was a skilled writer of popular mystery. His previous work had explored ancient civilizations, lost cities, unexplained phenomena. He knew how to build a narrative from accumulated strange detail. He knew how to present a collection of incidents in a way that felt not like coincidence but like pattern. And in the Bermuda Triangle, he did this with an ocean region that already had some reputation for strangeness, and he transformed it into something global. The book gathered incidents from across centuries: ships that had vanished, aircraft that had disappeared, compass anomalies, ghost vessels, unexplained lights. It drew lines between them and presented the triangle as a zone of genuine, active, ongoing anomaly. Something was happening there, something that resisted ordinary explanation, something that demanded a new framework for understanding. The incidents ranged across decades, even centuries, and Berlitz presented them as a coherent body of evidence. The cumulative weight of so many events, so many losses, so many open investigations, was exactly the kind of mass of strangeness that the popular mystery genre had always relied on. And Berlitz assembled it with skill and with conviction. The book sold millions of copies. It was translated into dozens of languages. It was adapted, excerpted, discussed on television, and cited by other books that cited those books. Within a few years of its publication, the phrase Bermuda Triangle was recognizable to people who had never heard of Fort Lauderdale, had never looked at a nautical chart, had never thought about the Western Atlantic in any detail. The name had become a kind of shorthand for a category of experience, the place where the inexplicable lived, the address the unknown had chosen. But researchers who went back to Berlitz's sources found something systematic: storms that the book described as calm weather, incidents that were placed inside the triangle's boundaries but had actually occurred outside them, sometimes hundreds of miles outside them. Ships listed as having vanished without trace that had in fact arrived at their destinations and been incorrectly entered into records that Berlitz used. Rescue explanations that existed in the original newspaper accounts but had been omitted from the retelling. Dates that were wrong, positions that were wrong. In some cases, the vessels themselves had been misidentified, and the incident attributed to a ship in the triangle had actually happened to a different ship in a different ocean. In some cases, the original sources themselves were inaccurate, and Berlitz had reproduced the inaccuracies without checking them against the primary record. This was not, in every instance, deliberate deception. Some of it was the natural result of working from secondary sources that were themselves working from secondary sources. Each retelling had smoothed the story slightly, removed the qualifications, emphasized the strangeness, and left the resolution quietly behind. By the time Berlitz assembled those accounts, the strangeness was all that remained. The explanations had been left at an earlier stage of retelling, uncollected, unfollowed, waiting in newspaper archives and naval files for someone with enough patience to go looking. In 1975, 1 year after Berlitz's book appeared, a library researcher named Lawrence David Cush published a book called The Bermuda Triangle Mystery Solved. Cush had spent years doing something that had apparently not been done before in a systematic way. He had gone to original sources, not the books that cited the incidents. The original newspaper accounts from the actual dates, the insurance records from Lloyd's of London, the naval investigation files, the weather service reports from the days in question. What he found, case by case, was that the legend looked very different from the inside of the primary record than it did from the outside of the popular retelling. Ships had sunk in storms that Berlitz's account had not mentioned. Aircraft had disappeared in weather conditions that, once examined, provided entirely adequate explanation for their loss. Cases attributed to the triangle had occurred in entirely different parts of the Atlantic, some of them thousands of miles from any reasonable boundary. The core of the mystery, Cush concluded, was not an anomaly in the ocean. It was an anomaly in the reporting. The mystery existed because the reporting had been selective, incomplete, and in some cases, simply wrong. Cush's book was rigorous. It was well documented. It was, by any standard of research quality, the more reliable account. It received respectable reviews in the publications that covered it. Researchers who followed his methodology and checked his work found that his conclusions held up under scrutiny. The primary source record, when actually consulted, did not support the legend that had been built on top of it, and yet the book sold a fraction of what Berlitz had sold. It made no comparable cultural impact. It did not generate a television special. It did not inspire a film. The legend continued producing books, documentaries, and fascination for the following 5 decades, as if Cush had never written a word. His work is cited in serious academic and investigative contexts. In popular culture, it barely left a mark. This is not because people are foolish. It is because Cush's book and Berlitz's book were answering different questions. Berlitz's book was answering the question of whether the ocean holds secrets. Cush's book was answering the question of whether the specific claims were accurate. Those are related questions, but they are not the same question. And the first question is the one that most people were actually asking. This is not because people are foolish. It is because Kusha's book and Berlitz's book were answering different questions. Berlitz's book was answering the question of whether the ocean holds secrets. Kusha's book was answering the question of whether the specific claims were accurate. Those are related questions, but they are not the same question. And the first question is the one that most people were actually asking. Most people who picked up Berlitz's book were not primarily interested in the precise locations and weather conditions of specific maritime incidents. They were interested in the larger feeling the book conveyed, that the ocean is larger than our systems for understanding it, that certainty is sometimes thinner than it appears, that the world contains zones where the ordinary rules seem to bend. Kusha's meticulous corrections addressed the evidence that supported that feeling. They could not address the feeling itself. The triangle persists not because the correction failed to reach people. It persists because the correction addresses the evidence and the legend addresses the feeling that preparation can fail without warning, that systems can come undone even when nothing obvious has gone wrong, that the ocean does not owe us our lives or our ships or our answers. Those feelings are real. They predate Berlitz. They will outlast any debunking. And they are feelings that the triangle, because it gathered so many stories in one place and attached them to a specific geography, gives a permanent home. You do not need to believe in anything supernatural to understand why the Bermuda Triangle persists. You only need to understand that human beings are meaning-making creatures, and that a place with this much accumulated loss, this much accumulated strangeness, this much depth beneath it, is a very efficient place for meaning to gather. The legend did not survive because the evidence supported it. It survived because something beneath the evidence was true, not in the triangle, in us. Chapter 10. What still goes down? After everything we have covered, it would be easy to arrive at a comfortable conclusion. The triangle was assembled from misreported incidents. The physical forces that shaped those incidents are well understood. Kusha traced the most famous cases back to their primary sources and found explanations waiting there. The legend is largely a product of selective retelling amplified by a book that reached millions. We can put it down and move on, but that conclusion would be incomplete. And incompleteness, in a story about a place defined by what it has kept from the world, deserves to be noted honestly and without apology. We live now in an era of technological surveillance of the ocean that earlier centuries could not have imagined. Satellites track the surface of the Atlantic continuously. AIS transponders, automatic identification systems, broadcast a vessel's position every few seconds to receivers on shore and in orbit. EPIRB beacons, emergency position indicating radio beacons, are designed to activate automatically on contact with water and transmit a distress signal and precise location to rescue services, regardless of whether any crew member is conscious or able to act. Weather satellites map cloud systems and sea states across every ocean basin in real time. Radar coverage from shore stations and airborne assets extends across significant portions of the region. The assumption that a vessel or aircraft crossing the Bermuda Triangle today is under continuous, complete, and reliable observation from above is reasonable and largely correct. It is not, however, entirely correct. AIS transponder coverage has gaps over the open ocean between shore-based receivers. Satellite AIS has improved this significantly in recent years, but satellite passes are not instantaneous and continuous. There are windows. Small vessels, recreational boats, and fishing craft are not required in all jurisdictions to carry AIS at all. A boat that departs without a transponder leaves no electronic trail except whatever it carries in the memory of the people who last saw it. EPIRB signals require the beacon to remain intact and functional at the surface long enough to transmit. A vessel that sinks rapidly in deep water, or whose EPIRB is damaged in the event that caused the sinking, may not produce a signal that reaches any receiver. The device designed to save you only works if it survives long enough to speak. Weather satellites map the tops of cloud systems in extraordinary detail. They cannot see the conditions inside a waterspout. They cannot resolve the behavior of a 6-meter wave at the precise location of a small boat. They see the cloud. They do not see what the cloud is doing at the surface level where a hull is. And GPS-based navigation, while transformatively more reliable than anything available to earlier generations of mariners and pilots, has its own vulnerabilities. Solar events of the kind we discussed in the Compass chapter can degrade GPS accuracy. Certain atmospheric conditions can affect signal propagation. The system that a navigator trusts absolutely may, in specific conditions, be less precise than its normal behavior suggests. Precision is not the same as perfection. And in navigation, the distance between those two things is where the accidents live. The result is a world in which the Bermuda Triangle is incomparably safer to cross than it was in 1945 or 1918 or 1492, and in which losses, when they occur, can usually be investigated with far more speed and thoroughness than was possible in those earlier eras. But not a world in which losses do not occur. The United States Coast Guard continues to receive distress calls, overdue vessel reports, and missing aircraft notifications from the general area of the Bermuda Triangle on a regular basis. The majority are resolved. Mechanical failures that did not become fatal. Boats that sheltered in unexpected anchorages during weather and did not report their change of plan. Aircraft that diverted to alternate airports and failed to notify anyone. Communication equipment failures that made a routine crossing appear alarming from the outside. The overwhelming majority of incidents in this region have explanations that emerge quickly once the investigation begins. Some do not resolve quickly. Some do not resolve at all. Small private aircraft, recreational vessels, and fishing boats that operate without mandatory AIS, without professional crews, and sometimes without filed flight or float plans, continue to disappear in this region in ways that leave incomplete answers behind them. The ocean's depth, the current's reach, and the scale of the search area mean that even with modern resources, wreckage is sometimes not found before weather and time and current have scattered it beyond useful recovery. The investigation closes not because the answer was found, but because the evidence is gone. What has changed between the era of Flight 19 and today is the size of the margin. Modern navigation systems mean that navigational disorientation of the kind that almost certainly contributed to Taylor's loss is far less likely. A pilot today who becomes uncertain of position has GPS confirmation available within seconds. Modern weather forecasting means that the rapid storm development that could trap an unprepared crew in 1945 is now, in most cases, visible on a device in a pocket hours before it arrives. Modern construction means that vessels are more survivable in extreme conditions than their predecessors. The emergency response infrastructure, the Coast Guard assets, the communication systems, the satellite coordination that now supports a search and rescue operation is orders of magnitude beyond what existed in December of 1945. The margin between a difficult crossing and a fatal one has widened enormously across the decades. It has not become infinite. There is a third category of experience in this region that exists entirely outside the official record. Pilots who fly the routes between Florida and the Bahamas and the Caribbean regularly, charter captains who have made these crossings hundreds of times, fishing crews who work these waters professionally, carry a body of informal knowledge about the region that does not appear in any investigation, report, or incident database. The conversations happen at fueling docks and airport lounges and over the radio between vessels that know each other. Descriptions of weather that formed faster than any forecast suggested. Encounters with current behavior that seemed inconsistent with the charts. Instrument anomalies that resolved themselves and were never severe enough to declare an emergency, but were notable enough to be worth mentioning to someone who had also been there. Conditions that experienced operators recognize and navigate around without filing a report because nothing happened. The near misses are not counted. Only the outcomes that produced something official are in the record. This informal knowledge shapes behavior in ways that are real but invisible to any statistical analysis. Experienced operators in this region carry extra fuel margins that go beyond what regulations require. They check weather more frequently than the minimum standard. They file float plans even when not legally required. They pay attention in a specific way that is hard to quantify but entirely real and entirely earned. It is the accumulated wisdom of people who know that this stretch of water, while not supernaturally dangerous, deserves a quality of attention that it does not always receive from those crossing it for the first time. The technology has changed, the ocean has not. The Gulf Stream still runs at 4 knots through the Florida Strait. The weather still builds over warm water faster than any forecast can fully predict. The trench north of Puerto Rico is still exactly as deep as it has always been, waiting in absolute darkness for whatever falls into it. The triangle is not solved. It is better understood. And understanding, as everyone who crosses it regularly has learned, is not the same as safe. Never has been, never will be. The ocean does not accept that kind of bargain. It only accepts the attention you bring to it, and returns whatever it decides to keep. Chapter 11. The Seafloor's Hypothesis. The ocean floor beneath the Bermuda Triangle is not inert. It is not simply a flat surface of rock and sediment sitting quietly under enormous depth. It is a dynamic geological system that has been active for millions of years and continues to respond to the pressure and temperature of the deep ocean in ways that scientists are still working to fully characterize. And within that system, there exists a substance that has generated one of the most scientifically interesting theories in the entire history of Bermuda Triangle research. That substance is methane hydrate, and it is worth understanding carefully because it sits precisely in the territory where real science meets speculative application. Both parts of that description are true, and neither should be allowed to cancel the other. Methane hydrates are sometimes called fire ice. The name comes from their appearance and their behavior. In their natural state at the bottom of the deep ocean, they look like ordinary ice. White, crystalline, solid. But they are not ordinary ice. They are a structure in which molecules of methane gas are trapped inside a lattice of frozen water molecules. The freezing is not caused by cold alone. It is caused by the specific combination of very low temperature and very high pressure that exists in deep ocean sediments, typically at depths below 300 meters, and in water cold enough to support the crystal structure. Under those conditions, the lattice forms and the methane stays locked inside it, stable, frozen, held in place by physics that will maintain that stability as long as the temperature and pressure remain within their required range. Methane hydrates exist in deep ocean sediments around the world, including along the continental margin of the eastern United States. The slope where the shallow waters of the continental shelf drop away toward the deep Atlantic basin. The quantities are significant. Geological surveys have confirmed substantial hydrate deposits along this margin. Some estimates suggest that the total amount of carbon locked in methane hydrates globally may exceed all other known fossil fuel reserves combined. The seafloor here, in the general region that includes the Bermuda Triangle, contains frozen methane in quantities that are not trivial. Here is where the theory begins. Under the stable conditions of the deep ocean, those hydrates stay frozen. but stability is not permanent. If the temperature of the surrounding water rises, or if the pressure decreases, the lattice can destabilize. When it does, the methane inside is released. The ice melts, the gas escapes. And if the release is large enough and rapid enough, the result at the ocean surface above can be dramatic. In 2016, Norwegian scientists studying the seafloor of the Barents Sea off the northern coast of Norway found enormous craters on the seafloor. Some were hundreds of meters across and tens of meters deep. The features were not caused by any known geological process that could be observed at the surface. The seafloor simply had holes in it where there had been no holes before in any previous survey. The best explanation that the research team could support, based on the composition and geometry of the craters and the known hydrate deposits in the surrounding sediment, was explosive methane release. The methane hydrates had destabilized. The gas had accumulated beneath a layer of sediment. The pressure had built over time until it exceeded the sediment's ability to contain it, and then it had released suddenly, blowing a crater in the seafloor and sending a massive bubble of gas rising through the entire water column toward the surface. The event would have been invisible from above until the bubble reached the surface, and then it would have been very visible indeed. In 2003, researchers at Monash University in Australia conducted a controlled laboratory experiment. They built a scale model of a ship hull. They introduced a large gas bubble beneath it in a tank of water. The result was what the researchers described as catastrophic. The gas bubble rising beneath the model hull drastically reduced the effective density of the water below it. Buoyancy depends on that density difference. When the density dropped, the hull lost buoyancy and sank rapidly, without any external force, without any weather event, simply because the water beneath it had stopped being water in the functional sense and had become a gas-water mixture that could no longer support a floating object. The mechanism is theoretically devastating for any vessel caught above it. A ship sailing in calm conditions, in good weather, with no mechanical problems and an experienced crew, might encounter a large methane bubble rising from a seafloor destabilization event below it. The water ahead would appear normal. There would be no warning visible from the bridge, no change in barometric pressure, no change in the sky, no alteration in the behavior of the sea at any point visible to the crew. The ship would sail into an area where the ocean density had dropped sharply, lose buoyancy in seconds, and sink before any distress signal could be sent. The crew would have no time to act. The ship would leave no floating wreckage because the violence of the sinking in reduced buoyancy water would be downward, not outward. The methane, lighter than air, would rise rapidly above the surface and disperse into the atmosphere within minutes. By the time any search aircraft arrived, the sea would be flat, the sky would be clear, and the ocean would show nothing of what had happened below its surface. This theory has been taken seriously by researchers precisely because the physics are real. The mechanism has been demonstrated in laboratory conditions. The geological structures that could produce such an event exist in the general region, but it must be clearly stated. The United States Geological Survey has examined the methane hydrate deposits along the continental margin of the eastern United States and has stated that there is no evidence of a significant large-scale methane release in the Bermuda Triangle region within the past 15,000 years. The geological record, as far as it can be read, does not show the kind of recurring destabilization events that the legend's scale would require. If methane releases were causing ship losses with the frequency that the triangle's reputation suggests, there should be geological signatures in the seafloor sediment of those events. Those signatures have not been found. The theory proposes a mechanism, a real one, a physically valid one. It does not explain any specific, documented incident. No ship loss in this region has been directly linked to a confirmed methane release event. The case for methane as an active explanation for triangle incidents rests on the mechanism being possible, not on any direct evidence that the mechanism has operated in this specific region in the relevant historical period. What the methane hydrate theory contributes to this story is therefore not an explanation for specific losses. It is a reminder, a valuable and honest one. The seafloor beneath one of the world's most heavily traveled maritime corridors is not static, simple, or entirely characterized. It is a geological system with its own dynamics, its own instabilities, and its own potential to interact with the ocean above it in ways that the surface traffic overhead cannot detect. That does not make it actively dangerous in a day-to-day operational sense. The probability of encountering a significant methane event on any given crossing remains extremely low. But it means the floor of the triangle is not simply an inert backdrop to a human story. It is part of the story, part of what makes this region something that rewards understanding rather than simply dismissal. The fire ice waits in the sediment, still, cold, held in place by pressure and temperature. And as both of those things are, very slowly, changing in the deep ocean over geological time, the question of what happens next is one that geologists continue to watch, not with alarm, with the careful attention that complex and dynamic systems have always deserved. Chapter 12. The Voices from Cockpits and Decks. We have spent several chapters inside the physics, the magnetic fields and the ocean currents, and the atmospheric dynamics and the geological structures beneath the seafloor. These are the forces that shaped the triangle's history. They are real and they are important, and understanding them changes how you think about the losses this region has seen. But physics does not have a voice. The people do. And in the records that exist, in the radio transmissions and the testimony, and the logbook entries and the investigation reports, there is a human dimension to this story that the physics cannot carry on its own. Professional aviators and mariners communicate with economy. This is not coldness. It is precision, trained into people who understand that in high workload situations, every unnecessary word is a word that could have been a critical piece of information. A routine radio position report is brief, to the point of seeming a mechanical: position, altitude, fuel state, heading, expected time to the next reporting point. If all is well, it takes less than 30 seconds. The brevity is the point. It is the sound of a system working correctly. The absence of elaboration is itself a form of communication. Nothing to report means everything is as planned. When everything is proceeding normally, there is nothing to explain. And when that normal brevity shifts, even slightly, even in a way the speaker has not consciously registered, the people listening recognize it. The pattern has broken. Something has entered the system that the system was not expecting. When things begin to go wrong, the communication pattern changes, and the change is detectable before anyone has declared an emergency. Sentences grow shorter, then shorten further. Information that was given once begins to be repeated without being asked for. Questions appear where statements were appropriate. The characteristic steadiness of professional radio communication acquires a quality that controllers describe, in the careful language of their field, as atypical, not alarmed. Atypical. The competence is still there, the training is still operating, but something has introduced a weight into the transmissions that was not present before, something that the speaker may not have consciously acknowledged yet. In the recordings that exist from Flight 19, this pattern is clearly present. Taylor's early transmissions from that December afternoon are professional and composed. His voice is the voice of an experienced officer reporting a problem that he believes is manageable. As the hours pass and the fuel continues to drop and the darkness settles over the ocean and the attempts to fix position fail, the character of his transmissions changes. Not to panic, something quieter. A professional whose certainty has been steadily eroded, who is still performing every function of his role, who is still making decisions and giving instructions. But who has stopped sounding like someone who knows where they are? The most revealing transmission of the entire Flight 19 record is not the last one. It is one of the intermediate ones, hours into the ordeal, when Taylor is recorded asking a ground station not for a bearing, which would have been the standard navigational request, but what appears to be asking for confirmation that his radio is working. A man with 2,500 hours in the air asking whether his radio is functioning. The radio was functioning. The question was not about the radio. It was the expression of a mind that had begun to doubt every instrument, every system, every assumption about the environment it was operating in. When the information the world is providing stops making sense, the mind begins to question the tools it is using to receive that information rather than accept that the information might be valid and its own map might be wrong. It is one of the most human moments in the entire transcript, and one of the most heartbreaking. The final transmissions of Flight 19, received intermittently and with degrading signal quality in the hours after dark, describe Taylor preparing his men for ditching. For landing 5 aircraft simultaneously on the open Atlantic at night, in building seas, without landing gear, without lights, without any information about the sea state below them, his instructions are calm. His voice, as received, carries no detectable hysteria. A senior officer giving orders in the worst possible set of circumstances, with nothing left to use except the discipline that 2,500 hours of flight time had built into him over years. And then the signal weakens. The transmission falls below the threshold of what any receiving station can distinguish from static. And then there is only the static. Silence is not the same as absence. The men were still there somewhere, in 5 aircraft, in the dark over the Atlantic, following their last known heading on a fuel state that was measured in minutes. The silence was not the end of their experience. It was the end of our ability to be present with them. That distinction matters. It is a distinction that belongs not only to Flight 19, but to every vessel and every crew that this region has taken. The ocean closed over them. The signal stopped. But the last moments before the silence contained human beings doing exactly what human beings do when systems fail and options narrow. Working the problem, giving instructions, hoping. The record does not preserve what happened after the last transmission, but it preserves enough to know that the people in those cockpits and on those decks were not passive victims of mystery. They were people doing everything they knew how to do, right up until the point where doing everything was no longer enough. Maritime testimony from surviving crew members of ships that encountered severe difficulty in these waters carries its own patterns. Investigators who have reviewed these accounts note something that psychologists would recognize immediately. The period during which a situation is clearly deteriorating, and no one says so directly. Not suppression, not denial, not a conspiracy of silence. Something more ordinary and more human. The culture of professional competence, especially aboard a vessel at sea where the commanding officer sets the tone and the crew reads that tone continuously and adjusts their behavior accordingly, makes it genuinely difficult to be the person who names the problem out loud before the commanding officer has done so. Naming the problem means proposing that the person in authority has not recognized it. That requires a kind of social courage that is difficult even in calm conditions. In a deteriorating situation at sea, under the additional cognitive load of managing equipment and monitoring systems and calculating options, it requires something that the training of the time did not always explicitly prepare people for. This is not a failure unique to the Bermuda Triangle. It is a failure mode documented in aviation and maritime incident investigations from every ocean, every airspace, every era of the modern record. It has a name in the safety research community: crew resource management failures. The recognition that the best trained, Most technically competent crew can nevertheless fail to arrive if the human dynamics of their working environment prevent critical information from reaching the person who needs it in time to act on it. Modern professional training in aviation and maritime operations now explicitly addresses this. Officers are trained to speak, to name the concern, to challenge authority when their own assessment diverges from the leaders and the stakes are high. That training has saved lives. It has changed the pattern of how disasters develop. But it came into existence because the pattern was already in the record, again and again, in accident reports from exactly the kind of conditions this region produces. The triangle did not create this vulnerability. It did not install it in these crews. But in a region where the physical environment already operates at the outer edge of what professional preparation can manage, and where a small delay in recognizing a problem can close the margin entirely, the human voice that does not speak at the critical moment is as much a part of the story as the storm that formed without warning, or the compass that pointed somewhere it should not have. The voices in the records speak. They are worth listening to, not only for what they say, for what they choose not to say until it is already too late to matter. Chapter 13. Survival and Disappearance. The Thin Margin. There is a question that sits at the heart of the Bermuda Triangle that is rarely asked directly. Not why do ships and aircraft disappear here, but why do so many more of them arrive safely? The answer to that question contains the real shape of this region's danger. And the shape, once seen clearly, is neither the supernatural horror of legend nor the simple reassurance that nothing unusual is happening here. It is something more precise, more human, and in its own way, more worth understanding than either extreme. Lloyd's of London is the world's oldest and most comprehensive insurance market for ships. They have underwritten maritime risk for centuries. They have processed the claims for losses in every ocean, in every era of modern shipping, across every route that carries commercial cargo. When a region of ocean presents a statistically elevated risk to vessels, Lloyd's knows it. They know it in a way that cannot be argued with because they are financially motivated to be right. Being wrong about elevated risk costs them money. They have no incentive to understate danger. They have every incentive to price it accurately. An insurer that charges normal rates for abnormal risk is an insurer that loses money on exactly the claims it should have anticipated. That is not a sustainable business, and Lloyd's has been in business for centuries. Lloyd's of London has not, historically, charged higher premiums for vessels transiting the Bermuda Triangle compared to vessels on routes through other comparably busy ocean corridors. The underwriters who examine risk for a living, who stake money on their accuracy, who have access to the complete claims record, have looked at this region and priced it the same as comparable routes. This is not a small fact. It is one of the most statistically grounded statements that can be made about the triangle's actual danger level. The actuarial record, built from centuries of claims data, does not show a region with anomalous loss rates. It shows a region with loss rates consistent with what busy tropical shipping lanes produce when weather, human factors, and mechanical failure are accounted for. The people whose job it is to be right about risk, and who pay a financial penalty for being wrong, have consistently concluded that this region does not represent an unusual danger. This does not mean nothing goes wrong here. It means the rate at which things go wrong here is not measurably higher than it is elsewhere on the ocean when normalized against the volume of traffic. The triangle carries more ships and aircraft than most ocean regions. More traffic means more incidents in absolute numbers. But the ratio of incidents to crossings is not exceptional. The legend, in other words, was built on the absolute number of losses and not on the proportion, which is the only number that actually speaks to whether the region is unusual. Now hold that fact alongside another one. The difference between a flight or crossing that encounters serious difficulty and survives it, and one that encounters the same difficulty and does not, is often not primarily a matter of skill or preparation. It is a matter of timing. A weather system that developed 2 hours earlier changes the encounter entirely. A headwind component that was not in the forecast adds 40 minutes of fuel consumption to a flight that was planned with a 30-minute reserve. A current that runs stronger than charted on a particular day places a vessel 15 miles further east than the navigator believed at the moment when the decision about which port to shelter in needed to be made. An instrument that fails at the beginning of a crossing rather than at the end of it gives the crew time to adapt. The same instrument failing with 30 minutes of fuel remaining gives them something else entirely. These factors are not under anyone's control. They arrive with the territory. They do not ask permission. They are simply the environment, operating as it always does on the day that a particular crew happened to be there. The pilot who flew through the same weather safely and the pilot who did not were not separated by competence. They were separated by what the environment was doing at their specific moment of passage. The first pilot cannot fully account for why they survived rather than their counterpart who did not. The conditions cooperated sufficiently. The second pilot did not fail at anything that competence alone could have fixed. The conditions did not cooperate. The margin was narrow on both occasions. On one of them, the narrow margin held just long enough. This is deeply uncomfortable to accept. We want to believe that skill determines outcomes. We want to believe that preparation is the variable that separates those who arrive from those who do not, because that belief gives us a sense of agency. If skill and preparation determine outcomes, then by becoming more skilled and more prepared, we can guarantee safety. That belief is motivating. It drives people to train harder, plan more carefully, carry more fuel. All of those things are good. All of them matter. But the belief that underlies them, that total preparation can produce total safety, is not accurate. It is a useful fiction that serves human psychology and drives good behavior. It is not what the accident record shows. Skill and preparation do matter. They shift the probability. They widen the margin. A trained crew in a well-maintained aircraft with a properly calculated fuel load and a current weather briefing is genuinely safer than the alternative. That difference is real and significant, but it is not total. It does not guarantee arrival. It only makes arrival more likely. In a region where the physical environment can produce rapid, severe, and compounding challenges, more likely is not the same as certain. There is also the factor of what researchers call survivorship bias. Millions of flights and crossings have passed through the Bermuda Triangle without incident across the decades since the legend formed. Those crossings are not in any archive of the unusual. They are not in any investigation report. They are not in any book about mysterious disappearances. They do not appear on any documentary. They are simply the background of normal operations against which the losses are counted, invisible to the counting. Because those successful crossings leave no record interesting enough to collect, our intuitive sense of the region's danger is not based on a representative sample of what happens here. It is based entirely on the subset of events that produced something notable enough to be recorded, investigated, and retold. The overwhelming majority of the data, which is the data of safe arrival, is absent from the picture we have constructed about this place. A picture built on only the losses will always look more dangerous than the full picture would support. This is not a flaw in human reasoning. It is a feature of how attention works. We notice what breaks. We do not notice what does not. And when we try to assess the danger of a region based on what we have noticed, we are assessing the danger based on the failures alone, with all the successes subtracted. That is what the Bermuda Triangle actually is when the data is laid flat and examined honestly. A heavily traveled region of ocean with real and serious physical hazards that are well understood and well documented. A history shaped by real losses in which real physical and human forces played entirely real roles. a legend built on selective emphasis that accumulated power because it spoke to something true about human vulnerability, even when the specific claims were not always accurate. And a reminder, durable and important across every chapter of this story, that even in well-understood and well-traveled environments, the margin between arriving and not arriving can be thinner than the confidence of any departure ever suggests. Most crossings arrive. The statistics confirm it. The insurance records confirm it. The fact that these waters carry some of the world's busiest maritime traffic and have done so for centuries confirms it. Some crossings do not arrive, and the difference between them is sometimes everything preparation can provide, and sometimes something no amount of preparation could have changed. Both of those things are true. And holding both of them at the same time, without collapsing into either pure reassurance or uncritical alarm, is perhaps the most honest relationship with this region that anyone can have. Chapter 14. Drifting Out. Still wondering, we have come a long way together tonight. From a tarmac in Fort Lauderdale to the bottom of the Puerto Rico Trench. From the radio transmissions of 5 men who could not find home to the insurance ledgers of Lloyd's of London. From the golden seaweed drifts of the Sargasso Sea to a library researcher tracing ship records back to their primary sources and finding the ordinary waiting where the extraordinary had been reported. From the geological fire ice locked in deep ocean sediment to the inner ear of a pilot flying without a horizon in the dark over the Atlantic. What we are left with is not a solution. The Bermuda Triangle does not solve cleanly. That is not a failure of the investigation. It is an honest accounting of what the ocean is, what history preserves, and what certainty actually looks like when you examine it closely enough to see its edges. There are cases in the Triangle's history where the reconstruction is genuinely incomplete. Flight 19 cannot be confirmed to a specific set of coordinates. The USS Cyclops has not been found. Several more recent incidents have probable explanations that remain probable rather than proven. These open files are smaller in number than they were before systematic research was applied to the record. They are not zero, and the irreducible uncertainty that remains in them is not an invitation to supernatural explanation. It is an honest acknowledgement that the ocean does not preserve evidence the way land does. That events reconstructed from fragments carry uncertainty that cannot always be closed. That some questions, even when they deserve answers, do not receive them. The triangle persists in imagination because it gives a specific geographic location to something that is not actually geographic. The experience of careful preparation not being enough. The experience of systems coming undone without obvious cause. The experience of certainty revealing itself as thinner than it had appeared. These are not experiences that belong to this particular stretch of ocean. They belong to anyone who has ever trusted a system and found it insufficient. Anyone who has ever prepared carefully and arrived somewhere different from where they planned. Anyone who has discovered that the gap between what is understood and what actually happens can open without warning and without particular fairness. The triangle gathered those experiences and gave them an address. That is what legends do. They do not create the feelings they describe, they collect them. They find the geography that fits, and they pour everything into that shape until the shape becomes the thing itself in the popular imagination. But underneath the shape, the real forces remain. The Gulf Stream is running right now, northward along the American coast, moving faster than a sailing vessel, carrying whatever drifts into it toward wherever the current decides to go. The warm ocean surface is generating moisture and instability that will be weather before the morning is done somewhere in that broad blue expanse. A cumulus cloud is climbing over warm water right now, growing vertically at a rate that makes it something entirely different from what it was an hour ago, with no one watching from close enough to notice the change. The hydrates are locked in the sediment at depth, cold and still, held in place by pressure and temperature that have maintained their stability for 15,000 years and are, very slowly, subject to forces that change. The trench waits at 8,000 meters, below the reach of any natural light, as it has waited through every crossing this region has ever seen, and every loss it has ever kept. The compasses are pointing toward magnetic north, which is not quite where any map says it is, and is moving as it has always moved, continuously and without announcement, across the Arctic Ocean, toward a position it has not yet reached. None of these things stopped working when the legend was scrutinized. None of them became safe when Kusha traced the ships back to their home ports and found the ordinary waiting where the extraordinary had been reported. They were there before the first story about this region was told. They are here now, tonight, while you rest. They will be here when the last story about this region is finally finished by someone who has not yet been born. What this region teaches, if we allow it to, is something worth carrying beyond the ending of this episode. It teaches that complexity amplifies consequences. That small deviations from plan accumulate into large ones if they are not caught early, because each deviation changes the starting point for every decision that follows. That trust in systems needs to be renewed regularly through active verification rather than assumed permanently through familiarity. That the absence of evidence for something going wrong is not the same as evidence that nothing will. That preparation widens the margin but does not guarantee the outcome. These are not lessons about the ocean. They are lessons about every complex system that any of us moves through every day, with the quiet confidence of someone who has done this before and arrived safely, and therefore expects to do so again. Drifting out of the triangle is not leaving behind a mystery. It is carrying forward a perspective, one that holds open questions without being destabilized by them. One that respects what cannot be fully explained without pretending that explanation is forbidden. One that takes the ocean and the sky above it and the depth below it seriously enough to pay attention. Not because something supernatural is waiting, but because the ordinary is already complicated enough to deserve that attention. The ocean continues tonight. The sky above it continues. Somewhere over warm blue water, a crossing is being made right now by people who checked the weather and filed a flight plan and calculated the fuel and are doing everything that careful and experienced preparation looks like. They are monitoring their instruments, they are talking to their crew, they are watching the horizon for the kind of cloud formation that grows faster than it should. They are doing the work that this environment demands and that good operators have always done here, and most of them will arrive exactly where they intended to arrive. They will land, they will dock. They will call home or send a message or simply take off their headset and sit quietly for a moment in the relief of having arrived. The crossing will become unremarkable. Another one of the invisible millions that form the silent background of the triangle's full story. And somewhere in the dark of that same water, the Gulf Stream is making its own plans for debris and distance. The compass needle is telling a story that the map does not quite agree with. The seafloor is doing what seafloors do in the long, geological dark, in a timescale that makes every human crossing seem like a breath. The triangle is being what it has always been. Not a mystery in the supernatural sense, a place where the world is complex enough and deep enough and unpredictable enough that simplicity is not available. Where the questions that stay open, not because something is hiding the answers, but because the answers are in a depth that has never given anything back that it was not ready to release. Drifting out of the triangle is not leaving behind a mystery. It is carrying forward a perspective, one that holds open questions without being destabilized by them. One that respects what cannot be fully explained without pretending that explanation is forbidden. One that takes the ocean and the sky above it and the depth below it seriously enough to keep paying attention. The sun is 93 million miles away, doing the things the sun does, quietly and without concern for anything in this ocean. The compass needle is moving, the current is running. And somewhere in the dark tonight, someone is crossing water that has no bottom anyone has ever touched. The wondering that remains is not the kind that demands resolution. It is the kind that stays curious. And in that specific kind of wondering, there is something that very much feels like rest. Good night.